I wouldn't go over spec because I think there's a tendency, I think today, for people going possibly a little bit over the top in terms of spec, because at the end of the day, more investment in machinery, it is an additional machinery cost. So, I'd have no problem, 24 meter, relatively simple trail sprayer, even mounted a sprayer would manage that area. There are options for having front and rear mounted that can bring you up to 3,000 litres capacity if that's what you want to do.
Sprayer manufacturers are including more and more technologies to sprayers each year, but this technology comes at a cost. Will the newer technology improve the application of the product to the target area, or will it mostly just reduce the stress for the sprayer operator? You're listening to the latest episode of the Tillage Edge with me, Michael Hennessy. We would really appreciate it if you could listen, follow, and give us a review on Apple or Spotify, or wherever you get your podcasts from. A few weeks ago, I chatted to Dermot Forristal, a researcher in Teagasc, about sprayers and newer technologies. We continued this conversation this week as I asked Dermot about drift-reducing nozzles and if they can be developed further.
This is the real curious one because it has gone, they found a very simple technology that does the job extremely well. Okay, so if you went back, the first systems were, I suppose, air systems really to try and reduce drift. Now, you did have other ones. You had control droplet application and charge droplets, electrostatic spraying. But to move on from that, it was then you had, kind of curtain systems. Hardy were big with that, with the Hardy Twin, and there's still probably a role for that, actually. There is an advantage to it. There was an air tech system that combined pumped air with pump spray within the boom. So you had two pumps, one pumping air, one pumping spray, if you like, and they met at the nozzle. So they were drift reduction systems that were there. Then you had low drift nozzles that came in without air intake. And what those ones were they had a kind of an orifice, a restriction orifice. And then, if you like, it was a method of reducing pressure within the nozzle body. And that worked reasonably well, but they were a bit prone to blockage. But then the air induction nozzle came, which is the one that's used today, and produces a totally different nozzle size spectrum by literally allowing air into the nozzle at the point where it goes into the crop. So that's a very cheap technology that really does give us drift reduction. The downside to the system is that it does change the size of the droplets. That's how it works. So the droplets are bigger. And for most products, that's probably not a problem. But with some products that you're applying, they would benefit, or they should be applied with a different size droplet. In other words, a finer droplet than the air induction nozzle will give you. So that's where, back to the air curtain systems like the Hardy Twin or that, they'll allow you get the best of both worlds, if you like, but a much more expensive system. So you'll have standard nozzles with a stream of air pushing them down.
We talked about, or you already mentioned, a number of different systems, the pulse modulation, there's cameras or spot spraying, that kind of stuff. Which one of those type systems do you think will kind of win out from the benefit of getting a better application or a better control of your target versus cost? Because cost always comes into this.
It does, of course, yeah. Just the pulse width modulation, just to say what that is, that's nozzle technology, right? It's another way of giving you a hugely variable rate at the point of the nozzle, right? So instead of the nozzle giving a continuous stream out, it pulses it very rapidly, many, many times per second, right? And because of that, then you can turn up or down the amount of pulses that are there within the second.
At the nozzle, Dermot.
At the nozzle, yes.
Okay.
So they're an electronic nozzle with a very, very fast solenoid. And so they'll give you the advantage, the systems that had multiple nozzles at each point. It'll effectively do that for you and will do it very, very well. Except they seem at the moment, what's stopping them taking over, if you like, to some extent, is that they need to have very clean material going through them. In other words, they're prone to mechanical issues with if your water isn't really, really clean, if your product isn't really, really I suppose, well kept in solution, because these things are working so fast that they're prone to kind of blockage and maybe failure because of that over time. So that's what's holding them back. Now, whether, as I say, every manufacturer have options there at the moment in terms of that, but so that's really what they do. As I said, the multiple nozzle units do something similar. So both of those are there to give you the variable application rate. The question then is what controls that? Okay, so how do you make the best benefit out of that? It depends on the scenario that you're in. If it's, for instance, weeds, if you have weeds that grow in patches, that come from patches, something like sterile brome will normally start in patches. So what you want then is some way of identifying those patches, and then you only need to spray those patches. So that can be, it could be literally satellite imagery at a crude level. It could be drone imagery, or it could be a camera, or if you like, a sensor. It might necessarily be an ordinary camera wavelengths, but a sensor on the boom that seeks to recognize where the sterile brome is. Okay. And this is where the challenge has been for the last 10 or 15 years. The concept is there 30 years, but I suppose in the last 10 years, there's been more and more work being done on this, how to recognize those areas where there's a beneficial use for them. In other words, where it's something that will vary in areas, how to actually recognize that. And this is where your AI type technology, where you have, if you like, huge databases, that what you're trying to do is build up huge databases where whatever you're measuring that's looking at your crop is recognizing, this is a sterile brome patch, right? So I need to do something different here or to apply more something there. But look, it's going to be a long haul. Interestingly, there are separate companies setting up that are trying to develop that component and then maybe use that with a particular sprayer manufacturer. And I think that's a better way of it developing, rather than every sprayer manufacturer trying to develop that. It's better to have separate companies. And there's a certain amount of progress being made, and there are certain easy targets. Measuring docks and grassland would be easier than trying to pick out weeds in some other areas. And then there are other weeds and other diseases that there's going to be no benefit. You're never going to do that with septoria and wheat, because once you have conditions for septoria and wheat, the whole crop is going to have it. So you won't have the option of that. There, what you're trying to do is use a weather station or something like that to predict when it's going to occur, but not to variably spray it when it does occur.
Let's just put you into a situation where you have a 300-acre farm, of which you'll be farming for the next number of years, and you're in the market for a sprayer. And let's just say the world's your oyster. You can go for any make or whatever model you want. That's on the market in Ireland. What would your key specs be for that?
I think my key specs at the moment mightn't be too high. In other words, I'd be inclined to wait and see a bit. The real market that's out there at the moment is skewed, if you like, or benefit by TAMs to some extent. People are making decisions on that basis, which is good because it means they do adopt technology, right? If it's a trail sprayer, I think you'll certainly benefit hugely from having GPS and section control and auto headland shutting on and off, because it's hard to get it right without those systems. I would be also interested, I suppose, in marrying any system like that into something like an RTK GPS type system, because I think if you look, and anybody can do this, if you look on Google Maps and look at all the 24-meter tram lines out there and count in a few fields, 10 24-meter tram lines should give you 240 meters. It often gives you about 220 or 225 meters, which means that every run there's an overlap, right? So getting the precision right in that side of things would be beneficial. There's many ways of doing that. I won't go into that. But outside of that, I'd be struck by the fact that it's a 300-acre tillage farm. I wouldn't go over spec, because I think there's a tendency, I think, today for people going possibly a little bit over the top in terms of spec, because at the end of the day, more investment in machinery is an additional machinery cost. So, I'd have no problem 24-meter, relatively simple trail sprayer. Even mounted sprayer would manage that area. There are options for having front and rear mounted that can bring you up to 3,000 liters capacity if that's what you want to do. So I wouldn't go way over the top in terms of spec on that, because I think your good basic sprayer, a good boom, yes, I think you need stability. We didn't talk about that. You need stability in your boom. So a good boom suspension would be very important, so that you have a good constant nozzle height over the crop. But your air induction nozzles will work extraordinarily well in terms of capacity for spot spraying, either having multi-switching nozzles, pulse width modulation. At 300 acres today, I wouldn't dream of it. I'd wait for that technology to develop beyond where we are now before doing that.
And just to throw one other thing in terms of that 300-acre decision you might make, whether a guy was going to put in liquid fertilizer into that system, do you need a sprayer with a dual line type scenario? Do you need a boom that is an aluminium boom, or is that all just really racking up the price for everything?
It is racking up the price. I think, look, there's a certain advantages in liquid fertilizers. There's no doubt about that, right? So, but remember a couple of things. One is it's heavier, right? So it's maybe 1.25 times the weight of water. So it's putting a little bit more pressure on the system that way. And the other thing that it definitely needs is a different set of nozzles. How it gets out to those nozzles will vary depending on the sprayer type. So I think you'd need to talk to the sprayer manufacturer and look at the specs that they're offering to do that. The other thing that I'd say is hugely important if you're putting out nitrogen or something like that with a sprayer type is go back to what I mentioned about the overlaps there earlier. In other words, that's where you would benefit from your RTK technology to make sure your tram lines are at that 24 or whatever your tram line width is. Because if you don't get that right, if you are only spraying 22.5 meters wide with your 24-meter boom, then you have 1.5 meters or whatever at the side that is double the amount. Okay, not just 20% more, 30%, is double. Or if you miss it, you're going to get zero. So the importance of GPS for switching on and off in the headlands and having that system set right is hugely important. The importance of having tram lines that are true overall width is very important as well. So those things really need to be looked at there when doing that. And also the fact that you have one machine now that you may have a little bit of a clash in terms of demands at a particular time of year, when you're trying to put out maybe some top dressing with fertilizer, but you also want to spray something else. So to be mindful of that. So yeah, some advantages with the liquid end system, but just be a little bit careful.
Dermot, listen, as always, a mind of information, some really good information there for everybody. So listen, thanks again, and we'll be talking to you again shortly.
Thanks, Michael.
And finally, if you enjoyed the podcast, then recommend it to a friend or colleague. And as always, rate, review, and follow on Apple or Spotify so you never miss an episode. And for more information, go to teagasc.ie. I'm Michael Hennessy, thanks for listening, and I'll be back next week with more tillage news and advice.